Hello, everyone, and welcome to the CTO Forum. All right, I'm Raouf CHEBRI. I'm a developer advocate, but today I'm very excited to be here with you today. So I'm going to make this presentation in English. I hope that the people don't mind. But I met Marwan today, and I think that I should have met him before, because I'm going to talk about a lot of the things that he explored in his presentation. But I hope it's okay for everybody. But yeah, I'm excited to be here. I'm Algerian, so salam alaikum, everybody. And I have my friends that I haven't seen in a while. I have my parents who are upstairs watching me here, so I just want to say hi to them. So hi, everybody. All right, so this video that I just showed you is by a company, an exciting company that I love, that is based in China, that is called Unitree. And I think that they're doing amazing things in the area of robotics. Um, all right. And they're among many other companies that are doing exceptional things at reducing the cost of robotics for everybody. So I think that robots are going to be the new cars in the near future. And I don't know what near future means in this world of AI. It could be 3 years, could be 5 years, or 10. But the word of advice that I have for all of you guys who are in the technology sector is don't blink. Things are going super fast. Actually, this generative AI era might be maybe, oops, the clicker doesn't work anymore. Okay, yay, cool. This is how you know it's live. Okay, so the generative AI era might be the most important breakthrough of our generation, or maybe in any generation. And I think that we're going to hear more about, generative AI. We're going to hear more about AI in the years to come, and that's something that is inevitable. Um, and if you think about it, it's been only about 2.5 years since the ChatGPT moment, and AI models are just getting better and better every day. So here's a little prediction of what's coming in the next few years. First, I think we're going to hear more about AI agents. This is not very reliable. Hold on. Oops. Okay, maybe I need to get closer to the computer. Okay, so we're going to hear more about AI agents, especially this year. Everybody's saying 2025 is the year of AI agents, but what are these AI agents? It's just they are autonomous pieces of software and services that can do tasks. You can think of them as being little assistants that can perform tasks. For example, my company is working with a company called Replit that has built an AI software engineer that can build a mobile or a web application in a matter of minutes. And that's pretty cool. And I think we're going to see more and more of those autonomous systems. All right, and second is autonomous cars. And this is not the future, guys. This is something that is actually a reality. This is oops, hold on. Let me get back to this. Okay. Yeah, I just wanted to show you a video of actually me riding one of these autonomous vehicles in San Francisco. There's a company that is backed by Google called Waymo that has developed this. And it's kind of a freaky experience. So you get in the car, and then it drives by itself. There's nobody, and then especially the turns are kind of scary as well. But it drives very safely, and that's the most important thing. And you kind of get used to it really quickly. All right, and the third area, which I'm very excited about, and I think we discussed it a bit, is robots. And I think that we're going to see more and more robots, and that they're going to perform tasks that humans don't necessarily want to do. So you can think of any chores to garbage collection, etc. All of those tasks are going to be done by robots in the future, or in the near future. Which raises the question, how do we as individuals, as people, as a nation stay relevant in this world that is totally being redefined by AI? Well, to answer that question, let me take you to a place that I know really well, Geneva, Switzerland. So Geneva is the home to the United Nations, to great chocolate, and also to some of the greatest watchmakers. But it's also home to one of the most important experiments in the physics world. So CERN, which is the European Center of Nuclear Research, has built this particle collider underneath the city that runs hydrogen atoms at nearly the speed of light and collide them together to see what particle atoms are made of. And some of the breakthroughs are the Higgs boson. So this is just to give you perspective of what the experiment is like. This is Peter Higgs, who hypothesized about the Higgs boson that is the particle that gives mass to all particles in the universe. And he got the Nobel Prize for it. And this is me. I had the chance to visit visit the Hydro Collider 2 years ago as part of an event at the Postgres conference. And yeah, so the CERN is at the front, is at the forefront, and is at the edge of the technology. So there are many things that are being developed there. And one of the things that was created there that I think was cool is the World Wide Web. And we love the web. The web connects people. The web help people to interact and share information. And I think, but we need all that infrastructure in order to connect these people. This is what companies like Amazon did. They first started building their own infrastructure for their online bookstore, and then they decided to rent out the rest of that infrastructure to and create what we call a public cloud. So this is how it was created in the first place, and that allowed many people around the world to start building their applications, to start building their businesses, and create even more data. And all right. And as Marwan said, data is the fossil fuel of AI. Data is maybe the most important aspect of AI, but it's not the only one. But so in order to understand how data and AI are interconnected and are related, let's go and talk a little bit about mathematics. And I swear to God, I haven't spoken to Marwan before, but I wish I did. So here, I just wanted to show you a simple linear equation with y equals x plus 3. So for every value of x, for example, here if I have the value of 1, then I know the value of y. It would be 4. If x equals 5, y would be 8, and I can draw a line, and I can predict where that line is going. But if I show you this particular scatter plot, would you be able to identify which equation this is? It could be a linear equation, but maybe I can add another data point, and another one, and another one. And you can clearly see that it's not linear anymore, that it's something else, and maybe it's a quadratic equation. And this exercise, what you just did here, is create a model in your brains in order to identify that equation. And I think the human brain is exceptionally good at pattern recognition, but the computer is not so much. And this is why we needed to invent new techniques, like neural networks. And these have been covered before, and I love that we've spoken about transformers, etc. So that saves me lots of time. But we basically created these neural networks where we try to mimic what the brain does. Not quite, but that was the inspiration. And the entire idea is we give as much data as possible as input, and we try to predict the output. The more data we have, the better the prediction gets. But I think that one of the most important papers that came out after the attention is all you need about transformers is actually OpenAI's scaling laws that came out in 2020 that talks about the most important components of building a great AI models. And those components are the following. So data that we covered, model size, and also compute, so compute power. So we've already spoken about data. We've already covered the importance of data, and Marwan did the same. And today's language models have basically been trained over the entire internet, and we have a data problem. So this is why we speak about synthetic data, and we're trying to have LLMs create more data for us. And the model size, you can see it as adding more parameters to the language model. So in our equation, the more variables you add, the better the model gets. And third, last but not least, is compute resources in form of NVIDIA GPUs. And this is where the um, and this is where maybe the battle in the arms race is going on currently, because NVIDIA is not able to provide the entire world with GPUs, and we just need so much of it at the moment. And the reason we need these GPUs is because they're just so good at parallelizing computations and matrix computations that these AI models need for pre-training, but also for inference. And this is the real bottleneck at the moment. Okay, so just to give you a perspective, so ChatGPT, or the GPT model, is believed to be trained on a cluster of 30,000 GPUs, and XAI is believed to be having the biggest GPU cluster in the world with 100,000 GPUs. And yes, they're releasing their new model, Grok 3, today. So go and we'll find out more about these capabilities. But companies like Microsoft and others are buying as many GPUs as they can get. So Microsoft recently had made a purchase of 500,000 GPUs, which is just enormous for their training and for serving inference as well. And if you've read the news, you maybe heard of Project Stargate, where the American government is investing $500 billion in AI infrastructures, and all of that money is going to data centers. And it's believed that they will require 2 million GPUs for that AI infrastructure, which is huge. So why do we need more compute? Well, we want to make those models better. Also, what we realized is the bigger the models, the more emergent capabilities they get. So, for example, the models that you use, they're really good at translating text, but they've never been explicitly trained for that. And they're pretty good also at coding, but they've never been also explicitly trained for that. And also, text is not the only form of data that we have. We also have now other models, just like the OpenAI Sora, that takes text and turns it into a video, which is pretty cool. So now we don't need to have $1 million production in order to create a movie. We can just do it right from our basement, and that's pretty cool. All right, so now that we've spoken about data, model size, and compute, I would argue that there is another thing that we need more of, and that's its energy. And energy has become just so important because we need to power all those data centers. And Ilya, who is the co-founder of OpenAI, thinks that we're going to have the entire world is going to be covered with solar panels just to address the AI needs, and this is just how much energy we need in the future. And we can see also other companies, energy companies, making the move. So this happened just last week, where Aramco, so the Saudi Arabian company, invested $1.5 billion in creating the biggest cluster for inference. And they did that in collaboration with a company called Grok. And it's just, the world has changed. How come energy companies are also investing in AI? But it makes sense, because the price of intelligence, for it to drop, needs a lot of energy. And those energy providers can do that at a cheaper price. And I think this is one of the opportunities that our country has, because we have such an abundance in energy. So, yeah, things are going really, really fast. And to illustrate how fast they're going, I want to talk to you about Moore's Law. So Moore is the co-founder of Intel, and he had this prediction that the numbers of transistors on a chip doubles every 2 years. And this is not obeying any law of physics. It's just an observation that he saw in the market, and the and the law was pretty accurate because we've seen an increasing number of transistors inside the chips, and this is not linear, so this is in logarithmic scale. And I just wanted to talk about a little bit about the exponential growth that our brains are actually not capable of computing. So I wanted to take a moment to talk about that. There is this famous urban legend of the inventor of chess whose emperor was so pleased with this game that they told him that he can give him anything that he wanted. And all that he wanted was a grain and doubling the number of grains for each square of the chessboard that he created. So you go from 1 grain, 2 grains, 4, 8, 16, etc., all the way to number 64 over there. So I have a question for you. Can you guess the weight of that grain in square number 10? Any guess? This is about 36 grams. Okay, so the scale is manageable so far. But can you guess the weight at the 64th square? Any guesses? 100 tons? Slightly more than that. 645 trillion kilos. That's just unimaginable. And this is just to illustrate the power exponential growth, and this is just the power of 2. Now what we see in AI is what we call a hyper-Moore's law, where AI is getting cheaper, 10 times cheaper every 12 months. And actually, they're good, and AI's capabilities are doubling every quarter. So things are going really, really fast, and we really need to think about what we need to do. And also, there are potential breakthroughs in other areas. So, especially in the compute, in the compute section, and the energy industry. For example, now Google is working on, and not only Google, all the major companies are working on quantum chips, and quantum computing could be one of these breakthroughs that would help that would help not only AI but all the fields to compute much faster. And just to give you the sense of the difference between quantum computers and our current supercomputers, I have a video to show you. Son?
By our best estimates, a calculation that takes a Willow under 5 minutes would take the fastest supercomputer 10 to the 25 years. That's a 1 with 25 zeros following it, or a timescale way longer than the age of the universe. This result highlights the exponentially growing gap between classical and quantum computation for certain applications.
All right, so in that quick example that Google showed with their new chip Willow, so the computation that took 5 minutes in that quantum chip would take the entire age of the universe in order to be computed, so which is basically saying it's impossible to compute. And another breakthrough would be in the energy sector with fusion, with nuclear fusion. So nuclear has become a topic nowadays, especially because of the needs of all those AI clusters. And our current nuclear energy takes a heavy element, let's say uranium, and splits it into multiple other lighter elements and extract the energy from that. That process is called fission. But the sun, our sun, doesn't work that way. So our sun is a huge hydrogen ball that condenses all that hydrogen and heats it up to millions of degrees to turn that hydrogen into heavier elements, to helium, then carbon, and then to heavier other elements. And that process is called fusion. And fusion is a lot more powerful than fission. And because of the current energy problem that we have, a lot of companies are paying attention to fusion. There are some fusion reactors, sorry, but the problem with them as of now is that it just takes it's just too expensive to run a fusion reactor comparatively to coal or solar panels or just a fission reactor. But pay attention to this. This might change in the next few years. All right. So again, the question: how do we stay relevant in this world where that is completely redefined by AI? I found this really interesting article by Microsoft called "The Golden Opportunity of American AI" that I think is also applicable to Algeria to a certain extent. And it lays out a plan, a three-step plan, as following. First, build out the AI infrastructure. And build out the AI infrastructure. And as I mentioned before, Algeria is in a unique position to build out the infrastructure, especially with our energy capabilities, and I believe that we can do something about that. Build the AI skilling, and skilling means teach people how to use AI, because it's going to change the way we work, the way we teach our kids, so it's important to also integrate that into our daily lives. And third is AI export. So help the local companies to and facilitate all these exports of skills and expertise to markets worldwide. But we need to act now. So I think if you have to take away one thing from this presentation, is that the time is now. And I want you to get inspiration to start building now, to think of not in a future of 2, 5, 10 years, but think about what we can do now for this country. And also, the good news is there has never been a greater time in history to be in the technology sector, and we have a great opportunity as a nation, as individuals, to play a big part in shaping up the future of AI and shaping up the future of humanity. So next, the video. Thank you.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.